Hello everyone. We are again back with continuation of the old video that I have stopped in video number 5. So if you remember, we were talking about intramolecular aldol reaction, or we can say intramolecular aldol condensation reaction. So I'll just start from where I had stopped in my last video. So today the first topic that we will be starting, it will be called as retro intramolecular aldol. Retro intramolecular aldol. Okay. So now guys, retro intramolecular aldol is what? I hope most of you are aware about this word retro. Retro is used here to indicate that it is something which is going to be the reverse of aldol condensation or aldol reaction. So now in this case what will happen is you will be given a product, and from the product you have to find that which reactant underwent this reaction of so-called aldol to get this final product. Okay, for example, let's say if I take a compound like this, so let's say this compound is there which I have got at the, like let's say this compound, because OH is there. So for example, let's say this is the compound that I have got at the lower temperature, and one more compound is there. You know how to form that compound, it's alpha beta unsaturation. So one more compound exists here. So both can be given to us for retro intramolecular aldol. Okay, that looks something like this. And this is the product at high temperature, and I know how to like I hope that you know how to reach from here to here. Okay, so that is the main trick I told you in the last class. So this is the H which goes out from here, and OH which goes out from here, and you get minus H2O, and that is how a pi bond comes into picture. So let's say for both the cases which are given to us, we have to draw the reactant. So what are we going to do in this case? Let's say we get the product at a low temperature. So what are we going to do, guys, is, okay, what is the concept that we are going to do is, so first if you can see, we will follow the same numbering scheme as we have done. So we'll write it 1, 2, okay, 3, 4, 5, 6 and 7. Here also we'll write only 1, 2, 3 because complete numbering as of now is not required. Okay, now what we are going to do in this case is we are going to break the bond between 2 and 3. What I am saying is we are going to break this bond between 2 and 3, and we are going to convert this OH. We'll convert this OH into a carbonyl carbon. So as we convert this OH into a carbonyl carbon here, so what do we get here is, we'll get something like this. So this bond is anyhow broken. So this will be the reactant in this case. In this case also what we can do is we can just remove this pi bond, and on this third carbon we can introduce a carbonyl carbon, so we'll get the same reactant again. So this concept is called as what? This is called as retro intramolecular aldol. Basically what is the only important concept in this is, whenever you are doing the reaction of aldol condensation or aldol reaction, we have to just check that whatever products we are making, okay, if temperature is not mentioned, in that case, what do? Is we finally make the product as the condensation product. Okay, so there are some more examples that we can take in this case where we can form the product. Similarly, we'll see some more reactions here. Okay, so what numbering can we give here, guys? So we can tell that number 1, 2, 3, 4, 5, 6, 7, right? Or we can also draw like this. I hope that is also okay with you. If I am drawing it in the form of a straight chain, okay, a straight chain I will be drawing like this. Anyhow, you know that ketone group is a non-chain terminating group. So, ketone group is a non-chain terminating group. So, it means that it can never occur at the ends. But aldehyde is a chain terminating group, which means that it will always occur at the end of the chain. Okay, these are the basic concepts. I hope everyone is aware about. So, numbering, guys, if I do here, so this is 1, 2, this is 3, 4, 5, 6 and 7. So I think I have made myself very much clear by this question actually. So how should I draw the retro product? Okay, so I was talking about one more question that we are going to discuss here. Let's say we have another ring that I am drawing here that looks somewhat like this. So this is the product. We just want to know the reactant. What was the reactant? So guys, if you can see that there is no OH group present here. So one thing which we can assure is that it is the final product after condensation, right? So it is a product of what temperature? So it is the product for high temperature. Okay. So if we are getting a high temperature product, what we can do here is we can make this pi bond, we can break this pi bond, okay, and as I told you guys, what we are going to do is I'll draw the final structure here. Okay, we'll draw the before that you should know how to number this. So I'll start the numbering from here. It will go like this: 1, 2, okay, 3, 4, 5, 6, 7, and if it is continuing, we'll continue like this: 8 and 9. So for sure, if I am going to draw it as an open chain, it is going to be what numbered chain? It is going to be a 9-membered chain. So I'll draw a 9-membered chain here: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, guys, and where is my carbonyl carbon going to come? Third carbon, and it is also going to come on which carbon, guys? 6th carbon. Okay, so this is what 1, 2, 3, 4, 5, 6, 7, 8, 9, and this time it is not an aldehyde, it's a ketone. Okay, same structure you can also draw in another way. How can we draw the same structure as? Or we can also draw the structure like this if you want, like just showing you how the reverse of condensation is happening here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Where is my carbonyl carbon, guys? It's on the 3rd carbon and it is on the 6th carbon. That's it. Or means you can draw the structure in any of the ways. So I think guessing the reverse product is not a big deal, and there's no rocket science in this. Okay, basic concepts are there which if you can understand, you can easily get through it. Okay, So in the last class only I told you guys that there is one more method that I'm going to be talking about instead of this numbering. There is a method which is basically more of a mechanism method that will help us to decide the product as well as the reverse aldol condensation products. So that we are going to see. Okay, or you can say that as method 2 to find the product. This is the second method that I am going to tell you about, and again we are going to see this method with the help of mechanism of Aldol. Okay, so first we will see like a basic mechanism of Aldol and retro-Aldol. I will show you both the mechanisms, and then we'll talk about the other parts, that intramolecular aldol and all will be carried on after this topic. So let us talk about the mechanism of aldol. So if we are talking about mechanism of aldol, guys, it looks something like this. Okay, so if you are aware about, so what compound have I made here? Can anyone tell? Yes, what is the compound, guys, that I have made here? Any idea? Can you name this compound? Okay, now what is going to happen is this is going to react with OH minus. So I have started, I'll be writing the mechanism of the reaction. Okay, now what happens in the first step is this OH minus attacks the hydrogen here, and this hydrogen gives its electron here. So what ion we get here in the first case? Okay guys, what ion we get here in the first case? This is called as enolate ion. What ion we get here in the first case is called as enolate ion. Okay, now what happens to this enolate ion is, we have this enolate ion. I'll show you the second step here. This enolate ion that we are having, okay, reacts with another mole of the same reactant. What I'm saying is, this reacts with the another mole of the same reactant. Now here, guys, what is going to happen is, just see some arrows I will be drawing, which is of great importance to us. Okay, so what will happen is, okay, so this arrow and this arrow, if you can see both the arrows very properly, simultaneously this is going to happen, that the pi bond will break on oxygen, and as the pi bond breaks on oxygen, there will be a development of there will be a positive polarity that will develop here, and the negative charge is going to attack here. Okay guys, so ultimately can you imagine and draw what exactly is going to be formed here? Can anyone tell me what is going to happen here? Any idea, guys? So you'll get an O minus here, this will be your, and this is nothing but this is your H. Sorry, I missed it here. This is your H. Okay, so this is what you are going to get something. Okay, I hope you understand how this reaction has happened. Fine. Now what is going to happen next is what is going to happen is, water is going to come into picture. Okay, this bond will break like this, and this negative charge will take away the proton from here, and finally, guys, what are you going to get is your final product that will look something like this: OH, double bond O, and H. Clear? Now further, when you go for the aldol condensation, I hope you know what will happen. Alpha beta unsaturation will take place, and there will be a development of pi bond. Okay, there are two possibilities. If this is the carbon, this can be removed or this can be removed. Can any one of you in the comment box tell me which alkene, which double bond formation here, okay, will not say it as an alkene, which double bond formation here will be more favorable. So if you use the basic concepts of GOC, you will be able to understand that. So this is all about the mechanism of aldol. Now we are going to talk about the mechanism of retroaldol. Okay guys, what I am going to tell you is about the mechanism of retroaldol. So just see here. Heading is retroaldol mechanism. What is the heading guys? It is retroaldol mechanism. So in retroaldol mechanism, what is going to happen? I'll take the product that I've got. Okay, so this is the product I've got, and this product I will make it to react with OH minus. Okay, now let's see what is going to happen one by one. Okay, this OH minus, what will it do? It will take away this H plus and it will give its electron to this oxygen. So as you can see, it's a reversible reaction. It's going to be a very slow reaction here. So yes, what will I get here is guys something like this, O minus, and this will be double bonded oxygen and this will become my H. Okay, this will be the H. I hope this step is clear to everyone what has happened here. Okay, so next what is going to happen here guys is that this bond will break. Okay, and after this bond breaks, I hope you can understand what is going to happen here is you will again get your enolate ion here. If I am talking about the left hand side, plus of enolate ion, you will get something like this. Okay guys, now this minus sign will be satisfied by what? I hope you can at least know that it's aqueous solution, so this will be satisfied by H plus ion. And finally guys, what are we going to get are my two reactants here. Let's see what are the two reactants I'm going to get here. Will we get the both reactants back or not? That is what we need to check. Okay, so these are the two reactants that we got back. Okay, these are the two different reactants that we have, these are the two reactants that we have got. Okay, so this is how the retroaldol mechanism works actually, and if you have understood the mechanism, I hope any reaction for you is not going to be tough. Correct, any reaction for you is not going to be tough. Okay, now one more small concept I'll tell you here. Okay, anyhow you are aware about that aldol condensation, so let me show you one reaction here. OH. Okay, so let's say guys, this is my alpha, this is my beta. So what did we study? HOH, fine, heat, minus H2O. What do we get here guys? We get something like this. We get a double bond here. This is called aldol condensation, right? This is called aldol condensation. But how can we write the mechanism for the same? If we have to write the mechanism for the reaction that I have shown you here, how many of you can pause the video and try to write the mechanism for this? Okay, if you can imagine guys the mechanism of a particular reaction, the reaction actually becomes very easy for us. So just imagine what is going to happen next and how can you make this product. So please pause this video and try once. Okay, now I hope everyone would have tried. So now I will show you how is this going to happen. I'll mark this as H, this is double bond O, and this is OH. Okay, one more thing guys, like if you can check here, this was my H, so I'll continue writing it as H only. Okay, to make sure that it's not methyl group, I'm writing it as H. So here what I'll do is I'll write OH minus. Okay, so OH minus is first step is what? This OH minus will take away the hydrogen from this alpha position. Hydrogen will give its electron here. Okay, so what is going to happen next is, any idea? What is going to happen next is something like this. H double bond oxygen minus charge is going to come here, and this is the OH group. Now there is very interesting fact that I will tell you. There are two ways in which this negative charge can adjust itself to make the final product. So I'll show you as cases. Okay, case 1. Okay, case 1, what is going to happen guys? I'll show you here. I'll draw this thing again for you so that you can understand it in a better way. This is OH, this is negative, this is a double bond O. So what is going to happen here guys in this case is that this bond is going to break and this charge is going to move on this side. So finally what are we going to get here is, okay, what are we going to get here is this final product of aldol condensation. If you agree with me, you are going to get something like this. Case 2. I hope everyone would have understood this case. Second case, what we are going to do guys, case 2. Case 2 is, I am going to draw the same thing here again. OH, double bond O, charge. Fine. Now let's say, what is another way to do this guys? I'll shift this bond, oxygen bond here, and this charge if I shift here. Okay, now what am I going to get here is something like this. I'll get OH here, I'll get O minus here, and I'll get a pi bond here. This H is there still, keep on writing it. Sometimes I forget to write. Now what is going to happen here guys, next thing is going to happen here is a simple resonance. Okay, I'll show you how it happens. This charge will jump here, okay, and this charge will move here. So what is going to happen next, and one more thing is this OH is going to get out. These 3 arrows, can you focus? Arrow number 1, arrow number 2, arrow number 3. Focus on these 3 arrows happening simultaneously. Imagine and draw the final product and tell me, is it looking as the same as in case 1 or not? Please try to draw it guys and check whether it is looking same as in case 1 or not. You will get the same product. So I hope these 2 cases are very much clear to you, as well as the aldol condensation mechanism is also clear to every one of you. Okay, so let us try to write some mechanisms, very interesting mechanisms. We'll start writing, okay, and we'll try to form some products. Okay, so one such reaction will start. So I want every one of you to write down. So we'll take the case of propan 2-one. Okay guys, now we'll take the case of propan 2-one. There is no hydrogen. Actually on the terminal side there are carbons. Terminal side means instead of hydrogen we are taking 2CH3 group. I hope you know the molecular formula of this, CH3COCH3. So what is going to happen with OH minus ion coming into picture? I want you to explain this mechanism. How many of you can actually explain the mechanism, and the final product that you should form should be the product at high temperature. And we just not want the answer from you guys, we want you to write the mechanism and explain. I don't think I'm asking for much. So let's start. Okay guys, let's start and let's try to draw this. What are we going to do is, here is the reactant that we are having with us. So what I'm going to do is, I'm going to write the first step here guys. Let's say this is an H, the CH3. Okay, I hope now it makes sense. OH minus is going to take away this H plus, which is going to give its electron here. So finally what we are going to get guys will be something like this. Right, along with this there will be again an attack, as I told you, on the same molecule. Where will this enolate ion attack? It will attack here, and this will move like this. So what are we going to get next? Any idea? What are we going to get next will look something like this. So this is going to be our O minus. This is your double bonded oxygen. Okay, so if I count this as 1, 2, 3, and this is counted as 4, 5. So may I know guys where it is? 1, 2, 3, 4, 5, and one group here like this. I hope things are going fine for everyone. This and this basic things I'm writing. I'll write them, okay, always. So this is going to happen, and what are we going to get from here is something which looks like OH here, double bonded oxygen here. Correct? Am I correct or not? Can you please check? Okay, so this is what is going to happen here guys, and now we'll take this as alpha, we'll take this as beta, and since we are providing heat here in this case, okay, since we are providing heat here in this case, there will be a condition of minus H2O. So minus H2O means what guys? Any of the cases you can take. Okay, let's say this bond has already gone, there is an OH minus ion, okay, and that has taken that H plus from here, started heat from here only. So what we have got here guys is something like this, if I am not wrong. This is OH and this is a minus sign, and very close to the final answer. Okay, what is going to happen next is something like this. And finally, can you tell me what product are we going to get? Will look something like this. Okay, instead of down I have drawn the methyl group up. I think it makes sense. Sorry for missing the carbonyl carbon here. Yes, this is the final product. This is the aldol condensation product that we have got. Okay, pause the video and give a look to it. Only until and unless you see it 3 to 4 times, try to write it 4 to 5 times on your own, understanding each and every step. Then only you will come to know exactly what is happening in this case. Until and unless you do that, it's not going to strike in your mind. Okay guys, it is not going to strike anywhere to you until and unless you do this. Fine. So Shall we try with one more? This time I'm going to tell you something, or I'll give you a question which has got the concept of intra-aldol condensation. Intra-aldol condensation. Okay guys, question looks like this somewhat. Question looks somewhat like this. IUPAC name please. IUPAC name please. Okay, so let's write it down. One, two, three, four, five, six, seven, and ये आ गया here. This is H, and sorry, this is not H. This is carbon only. This one is your H, and that's it. OH minus. Give it a try. Give it a try very fast. Okay, find the answer with mechanism, and the final answer should be after heating the product. Whatever product you get, heat it, eliminate the water out of it, and then tell me the final answer. Give a pause and please try it. Okay, so I hope everyone would have tried. If not, you can see how am I doing this. So guys, first step remains the same. Okay, so I'm drawing something like this. What ion I'm going to get here is something like this. Double bonded O, double bonded O. Okay, if I'm not wrong with the length of the chain, I will start doing the numbering part. It's 1, 2, 3, 4, 5, 6 and 7. So what I will do is, now I will do the necessary part required. Okay, I will shift this electron here, and this pi bond I'll shift like this towards oxygen. Now there I go for a ring formation, guys. Very precisely, please look at this ring formation. It's going to be a 6-membered ring for sure. Okay, it's going to be a 6-membered ring. The second one has carbonyl carbon. This is your first. 2, 3, 4, 5, 6, if I am not wrong, has a oxygen with a negative charge, and it has one group like this. Now after this, it's like a very easy task. I hope every one of you would be able to do that. Okay, and you can easily get your final answer now. At least shown you the path, correct? So what are we going to get here is, okay guys, what are we going to get here will looking something like this. But what next? Is this our final answer? No, we have delta also here. Okay, so OH minus ion is still there, and if you are aware about, this is your alpha, and alpha has a hydrogen here, guys. So this OH minus is going to take away this hydrogen from you. Okay, and what are you going to get here is going to look something like this. I am not numbering it again and again. Okay, I hope that is clear to everyone. With a minus sign. Okay, with a minus sign coming up here. Okay guys, next step will be my last step, and a very important step. Okay, this goes here and this goes out. So finally what I'm going to get is a product which will look something like this. This is my final product. Again, my dear viewers, I would like you to write down its IUPAC name. Okay, I hope you're not feeling annoyed when I'm always asking you to write the IUPAC name, because that's the basic thing that I assume that every one of you should be knowing about. So without increasing the length of this video, guys, I'll leave each one of you with a small question which I would request every one of you to try and tell me the answer, so that in the next video I will be discussing this question. And with this question only we are going to start. And if it is a let's talk video, then we'll not discuss this. It's a let's chem video, yes, for sure we'll discuss this, and this will be the starting point of the next lecture. This question is given to us, okay, it says OH minus and this is given. So it's asking find all the possible products including stereoisomers. There is where that this question has played a game talking about stereoisomers. So if you can tell us the final product, and yes, a favorite triangle is here for sure. So if you can tell about the products as well as all the stereoisomers, tell me the number of the products, how many products are going to be formed, and including stereoisomers, total number will be how much. So please try to attempt this. I hope every one of you can, okay. And just a small thing, while writing the questions, because as you know it's organic chemistry, sometimes I might do mistakes. Instead of writing H, I might write CH3, or instead of writing CH3 I couldn't write H. Forgive me as a human being, that can happen as a error. It should not happen, will not happen with practice, okay. So guys, next video is going to be a more exciting video. Mostly it's going to be a let's talk video before I put another let's chem video. And the next let's chem video that I'm going to upload will be talking about some very famous named reactions mechanism which we have hardly heard about, or which we are more or less not taught in our day-to-day classes, whichever coaching you are being taking from, or whatever reactions you have read. So I'll dig in some very good reactions which are there in your, not if it means sure, in your advanced syllabus. And it will be a lot of lots and lots of information you can learn from those named reactions. Which named reactions, that is still let's keep it as a secret till we see the next video. So yes guys, so please do like, share, subscribe, share this video with maximum of your friends circle if you think that this video can be of any help to them. And do let me know for any suggestions that I have always asked you, but though I have not got any till now, but still waiting for some of your creative suggestions of how to make this video more interesting. Okay, so I think that's it for today. Okay guys, take good care of your health, stay blessed, stay happy. Signing off. Have a good day.